Welcome to this explainer. Getting data off the web today, it feels a lot like planning a high-stakes casino heist. The prize is the data, but the bank, well, it's a heavily fortified anti-bot fortress. For years, web scraping was just a simple game of cat and mouse, but lately, the mouse has been getting absolutely crushed. Today, though, we're looking at a brand new adaptive Python framework called Scrapling, and as you're about to see, it totally flips the script on modern web extraction. So let's set the scene here. The modern web is no longer just an open library. It is a high-security vault. We're talking about enterprise-grade guards like Cloudflare Turnstile, Datadome, Casada, and Akamai. Pages are no longer just static HTML. They're these dynamic, JavaScript-rendered labyrinths that are actively checking your TLS and browser fingerprints. And let's not forget the ultimate nightmare for any data engineer: those silent HTML structure changes pushed by developers at 3 a.m. They instantly break your carefully crafted selectors, and you just wake up to completely ruined pipelines, IP bans, and endless retry loops. So the burning question is, how on earth do you scrape a web that is actively fighting back? How do you consistently extract data when the environment is constantly shifting beneath your feet and trying to lock you out? You don't need to just keep hitting the wall harder. You need a smarter lockpick. And that brings us to Scrapling, which is structured perfectly for this exact problem. Let's break this heist down into 3 acts.
Act 1, the adaptive parser. Basically, your ultimate lockpick.
If the web is a vault, this is exactly how you get in. Notice how Scrapling approaches parsing. It's not just blindly hunting for a specific CSS class. It actually learns the physical shape of a page. You run your script once with auto_save set to true, and Scrapling takes a mental snapshot of the target elements. Then, when that website inevitably redesigns its layout in the middle of the night and those old selectors break, you just run it again with adaptive set to true. Scrapling's intelligent similarity algorithms kick in, and it automatically relocates the elements based on their characteristics. It literally heals itself. Your pipelines just keep flowing.
The contrast here is honestly pretty stark. With traditional scrapers, think BeautifulSoup. Unannounced DOM changes mean your scripts just shatter into pieces. They fail entirely. You have to manually intervene, dig into the code, and rewrite it. But Scrapling, it intelligently finds those similar elements to automatically recover the extraction pipeline. It adapts instead of breaking. But hey, being smart isn't enough when the alarms are about to sound, right? You also have to be fast.
And speed is absolutely non-negotiable. Look at these raw performance benchmarks for a text extraction speed test dealing with 5,000 nested elements. The numbers are wild. Scrapling barely even registers at 2.02 milliseconds. Raw LXML sits at 2.54 milliseconds. But check out BeautifulSoup for using LXML. It takes a massive 1,584.31 milliseconds. Just to put that into perspective, Scrapling's parser is roughly 784 times faster than BeautifulSoup for this kind of extraction. It's a lightning-fast, memory-efficient, and it guarantees your operations won't get bogged down when every millisecond counts. All right, Act 2, the 3 fetchers, or, as I like to call them, the disguises. See, once you've picked the lock, you still have to get past the guards. And Scrapling gives you 3 specialized tools right on your workbench. First up, the standard fetcher. This gives you blazing fast HTTP requests, HTTP/3 support, and it can seamlessly impersonate browser TLS fingerprints. Second, the heavy hitter, the stealthy fetcher. This one comes with full fingerprint spoofing and literally bypasses Cloudflare Turnstile and interstitials right out of the box. No extra configuration needed. And third, for when you absolutely must have full browser rendering, the dynamic fetcher gives you full playwright-driven automation for Chromium and Chrome. Let's look at how beautifully these tools compose together to create an impenetrable mask. Step 1. You manage persistent sessions across requests so your cookies and state look completely natural to the guards. Step 2. Apply built-in cyclic proxy rotation strategies. Step 3. Block the trackers. Scrapling has built-in ad blocking for about 3,500 known tracker domains, which massively speeds up your headless browsing. And Step 4. You route your queries through DNS over HTTPS using Cloudflare's DOH. That completely prevents any of those sneaky DNS leaks when you're using proxies. Act 3. The spider. This is your getaway vehicle. We have cracked the safe, we have bypassed the guards, and now we just need to haul the data out. Scrapling isn't just a basic script runner, it's a full-blown crawling framework. You get this really familiar Scrappy-like API using start_URLs and async parse callbacks. You get configurable concurrency, per-domain throttling, the whole deal.
But the truly powerful part is the multi-session routing. Within a single spider, you can route requests to fast HTTP fetchers for the public pages and then instantly switch to a stealth headless browser session for protected pages just by passing a session ID. Plus, you can stream all of these results live using async for item in spider.stream. Now, we absolutely have to talk about this killer feature because anyone who's ever run a massive multi-day crawl knows this exact pain. Say you need to stop your operation halfway through. With Scrapling, you literally just hit Ctrl+C. That's it. The framework gracefully shuts down and saves a checkpoint. When you're ready to get back to it, you restart by passing the exact same crawler, and your spider resumes from the precise checkpoint without losing a single byte of progress or duplicating any work. It's an absolute game changer for large-scale operations. And finally, the AI arsenal. One library, zero compromises. Pulling back to look at the bigger picture, Scrapling is truly built for the modern AI-driven era. Just look at this ecosystem. It features a built-in mcp-server, which means AI agents like Claude or Cursor can drive the extraction directly. This saves a massive amount of tokens because you're getting exactly the right data before it ever hits the LLM context window. There's a zero-code command line interface, so you can scrape a URL straight to Markdown or HTML. There's an interactive IPython shell for rapid trial-and-error prototyping, and the whole thing ships with a ready-to-deploy Docker image that has all the browsers pre-installed. And you can actually rely on it, too. Scrapling boasts 92% test coverage, alongside full-type hint coverage for perfect IDE support. It's automatically scanned with Pyrite and MyPy on every single change. This isn't just a toy, it's a battle-tested framework being used daily by hundreds of data engineers. Which leaves us with this final thought, and really the core philosophy of the framework: effortless web scraping for the modern web. When you actually have the perfect tool for every lock, a flawless disguise for every guard, and a vehicle that can handle the entire haul, extracting data stops being this frustrating endless battle. It becomes an art form. The modern web might be hostile, but with adaptive scraping, the real question is, now that the vault doors are wide open, what are you going to build?